Percival Lane Power Station, Runcorn. The Percival Lane Power Station in Runcorn was built and operated by the Mersey Power Company Limited. It comprised two stations and be commissioned in 1921 and 1941. The station supplied electricity to commercial, industrial, and domestic users over a wide area of 95 square miles around the River Mersey, including Widnes, Ellesmere Port and Runcorn. History. In 1911, the Salt Union built a vacuum evaporating plant at Runcorn to produce salt from brine. Steam was generated to drive turbo alternators. The exhaust steam from the turbines was used to evaporate brine. Only a portion of this energy was used in the salt works. The Salt Union obtained parliamentary authority to provide a public supply of electricity. This was through two electric lighting orders, the Runcorn Electric Lighting Order 1910 and the Widnes Electric Lighting Order 1910. Both these orders were authorized by Parliament under the Electric Lighting Orders Confirmation No. 1 Act 1910 10 Edwa 7 and 1 Gia 5 C. Ilxxv. A new company, the Mersey Power Company Limited. In 1918, the company resolved to build a large generating station at Percival Lane, Runcorn 53 to 1953 and 2 to 4525 W to meet the expanding demand for electricity. The company had local industrialists among its major shareholders and was able to promote and encourage the use of electricity by local industry. Percival Lane, a low-pressure station. The first station at Percival Lane was the low-pressure LP generating station, which was commissioned in 1922. Specification. The initial configuration of plant comprised boilers, 3x Babcock and Wilcox boilers with chain grate mechanical stokers. The evaporative capacity of each boiler was 45,000 lb/h 5.67 kg/s, giving a total capacity of 135,000 lb/h 17.0 k. The working pressure was 270 psi 18.62 bar and steam was superheated to 670 deg F 354 deg C. A cross-section through the boiler house shows the layout of equipment. The boilers supplied steam to alternators, 2x 12.5 MW Parsons tandem reaction turbo alternators, generating current at 6.45 kV. The machines have a steam consumption of 10 lb per kWh, 4.53 kg/kWh, exhausting to twin surface condensers. Ancillary equipment: turbine-driven feed water pumps delivering 175,000 lb/h 22.5 kg/s of water. Induced and forced draft fans, the former driven by a 97 HP 72.3 kW motor. U motor, U motor, U motor, W motor, U motor, U motor, an 800-ton coal storage bunker, supplied by a gravity bucket conveyor with a capacity of 40 tons per hour. Ash handling using a suction plant driven by a 120 HP 89.5 kW motor or by a water trough drag link conveyor, 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 circulating water system, 14,000 gal per min 1.6 m3/s pumped by 350 HP 261 kW pumps from the Manchester Ship Canal through 38-inch 0.965 m diameter pipes. Alternator ventilating fans delivering 50,000 cu. 1416 m3 of air per minute. Coal was supplied via sidings on a branch line from the London, Midland and Scottish Railway at Runcorn. Electrical equipment. A switch house contained ray-roll compound filled gear, which had a rupturing capacity of 750,000 kVA 33 kV switchgear and 350,000 kVA 6.6 kV switchgear. The 33 kV switchgear controlled two 132/33 kV main step-down transformers, two 6.6/33 kV step-up transformers, and 33 kV lines to Chester. The 6.6 kV switchgear controlled the three generators, the interconnecting and station transformers, and the various trunk feeders. A reactor house contained single-phase British Thomson Houston reactors. The outdoor transformers had a ratio of 6/33 kV. Those for the three Ellesmere Port lines were arranged in three banks, connected delta star. Other transformers were associated with the 225-mile 40.2 km lines to Crewe and the 100-mile 161 km line to Meantrog, North Wales. The distribution system included the provision of 161 miles 259 km of cables and 47 substations. Supplies of electricity to consumers were available at three-phase 58C 6.0 kV, 3.0 kV, and 440 volts for industrial consumers and single-phase 250 volts for domestic consumers. Operations. The loads and connections on the supply system in 1921-23 were: in 1922, the Mersey Power Company Limited obtained further statutory powers through the Ellesmere Port and Whitby and District Electricity Special Order 1922. The area of supply of the Mersey Company expanded to about 95 square miles, 246 km2. To meet increased demand, in 1926, a further 4 Babcock and Wilcox boilers and one further 12.5 MW Parsons turbo alternator were commissioned. The electricity sold 1921 to 1926. The electricity sold by the Mersey Power Company in GWH from 1923-36 was as follows. The effect on sales of electricity during Depression 1929 to 1933 is demonstrated in the graph. The sale of electricity generated an income to the company of £45,930 in 1922 and £72,853 in 1923. This gave a surplus of revenue over expenses of £2863 in 1922 and £15,382 in 1923. Subsequent company profits were £32,974 in 1925, £59,297 in 1926, £65,177 in 1923. Another generating station was operated by the company. This was the Westin Point gas-fired station comprising two 750 kW gas-fired generators. National Grid. Under the terms of the Electricity Supply Act 1926, 16-17 GR 5C 51, the Central Electricity Board (CEB) was established. The CEB identified high-efficiency selected power station that would supply electricity most effectively. Percival Lane was designated a selected station. The CEB also constructed the National Grid 1927-33 to connect power stations within a region. Percival Lane was a critical part of the grid as it formed the connecting point between the North West England and North Wales schemes and the Central England scheme. The grid enabled the company to provide bulk supplies of electricity to the Mid Cheshire Electricity Supply Company and to the North Wales Power Company. Percival Lane B high-pressure station. The Bure high-pressure station was built on an adjacent site in 1940-41. Specification: 6x 187,500 lb/h 23.62 kg/s Babcock and Wilcox boilers delivering steam at 425 psi and 825 deg F 29.31 bar, 441 deg C. This gave a total evaporative capacity of 1,405,000 lb/h 177.0 kg/s. The steam was fed to 3X English electric 30 MW turbo alternators, generating at 11 kV in 1946. Percival Lane Power Station sent out 603.89 GWh of electricity, operated at a load factor of 60.8%, and had a thermal efficiency of 2.65%. Nationalization. Upon nationalization of the British electricity supply industry in 1948 under the provisions of the Electricity Act 1947 10-11 Gr. 6C 54, the Mersey Power Company was abolished. Ownership of Percival Lane Power Station was vested in the British Electricity Authority and subsequently the Central Electricity Authority. At the same time, the electricity distribution and sales responsibilities of the Mersey Electricity undertaking were transferred to the Northwestern Electricity Board (NORWEB). Post-nationalization operation. Operating data for post-nationalization Percival Lane Power Station is summarized in the following tables. The decline in output from the station is evident in the fourth column. The operating parameters for Percival Lane BHP Power Station were as follows. In April 1951, of the 12.5 MW Parsons turbo alternators in the station was transferred to Wallasey Power Station. The Percival Lane Power Station closed in the late 1960s and was subsequently demolished. The 132 kV substation built to connect Percival Lane to the national grid is still operational.